Along the Red Sea coast, industrial facilities operate continuously to secure water for inland regions.
Seawater enters reinforced intake channels, built to withstand constant volume and salinity. Inside the plant, water moves through vast processing halls, arranged for continuous operation. Processed water is collected into main transmission pipes, designed for extreme desert distances.
From the coast, pressurized lines carry water across empty terrain toward distant population centers.
Intermediate pumping stations maintain flow, compensating for elevation and pressure loss inland.
Pumps elevate treated water into primary transmission lines aligned for inland desert transport.
Transmission pipelines exit the coastal zone, immediately entering open desert terrain. Pipelines extend in straight corridors, optimized to minimize friction and energy loss. Pressure monitoring stations appear periodically, embedded directly along the transmission route.
As distance increases, additional pumping stations reinforce pressure across long desert spans.
Pipelines cross elevation changes using gradual gradients engineered for continuous movement. Flow remains stable as desert conditions shift from coastal humidity to extreme dryness. Water approaches inland distribution zones designed to buffer demand and regulate supply. Regulation yards receive incoming lines, separating transmission flow from downstream distribution controls. Multiple valves adjust flow paths without interrupting continuous movement through the system. Water enters large buffering tanks designed to stabilize demand fluctuations inland. Tank levels rise gradually, absorbing continuous inflow from coastal pumping corridors. Excess volume bypasses storage through secondary outlets toward parallel inland routes.
Distribution pipelines realign, orienting flow toward distant urban and agricultural zones.
Pressure is reduced incrementally to match downstream network requirements. Controlled release maintains balance between supply stability and long-distance transmission demands. Water exits the regulation zone through multiple outbound corridors simultaneously. Each corridor is engineered to serve a specific regional load inland. Distance increases as pipelines extend beyond the immediate regulation perimeter. Additional monitoring nodes track flow consistency across extended inland segments. Pipelines maintain constant alignment, minimizing mechanical stress across terrain. Flow remains uninterrupted as desert conditions fluctuate throughout the day.
Transmission corridors begin approaching zones of concentrated inland demand.
The system prepares to transition from long-distance transport to localized distribution. Water enters inland balancing reservoirs built to stabilize supply before final distribution.
Reservoir inflow is spread laterally to reduce kinetic energy from transmission lines.
Water levels rise evenly across compartments designed for sequential release. Overflow channels activate only after predefined storage thresholds are reached.
Stored water exits reservoirs through controlled outlet gates toward distribution networks.
Outlet channels reduce velocity before water enters enclosed distribution systems. Flow transitions from open channels into enclosed regional supply conduits.
Distribution manifolds divide flow according to regional demand profiles.
Valve sequences adjust continuously to maintain balanced downstream pressure. Pressure reduction chambers protect downstream networks from transmission-level forces. Water exits pressure control zones at levels suitable for regional distribution. Regional supply corridors carry water toward multiple inland consumption centers.
Each corridor operates independently while remaining synchronized within the national system. Flow stability is maintained despite increasing network complexity inland.
The system now functions as a regulated inland water supply network. The system now functions as a regulated inland water supply network. Regional supply enters perimeter facilities that separate urban and agricultural distribution streams.
Urban-bound flow is filtered and stabilized before entering municipal networks.
Agricultural flow is routed separately, maintaining higher volume and lower pressure.
Urban supply enters covered reservoirs positioned near population centers.
Reservoir levels are adjusted continuously to match daily consumption patterns.
Urban distribution pumps activate at lower pressure for neighborhood-scale delivery.
Flow splits repeatedly as networks branch towards separate city districts.
Agricultural channels regulate delivery through gated, field-level controls.
Release schedules coordinate water timing across multiple agricultural zones. Urban demand peaks are absorbed by reservoir buffering without upstream disruption. Distribution networks operate independently while remaining hydraulically synchronized. System controls prioritize stability over maximum throughput during sustained demand. Minor flow adjustments propagate gradually through downstream networks.
Urban and agricultural systems settle into balanced, predictable operation.
Continuous supply is maintained without visible strain across the inland network. Sustained demand increases are absorbed by upstream buffering without altering downstream delivery patterns. Control gates adjust subtly, redistributing load across parallel storage compartments. Transmission input remains constant as downstream systems absorb variation internally.
Pressure control chambers operate within narrow tolerances during extended operation. Distribution flow is prioritized automatically based on preset regional requirements. Agricultural delivery rates are reduced incrementally to preserve urban stability.
Urban reservoirs compensate immediately, maintaining constant neighborhood supply.
Flow adjustments propagate slowly, avoiding pressure spikes throughout the network. System performance remains predictable despite prolonged operational strain.
As demand stabilizes, temporary adjustments begin reversing in sequence. Reservoir levels return toward mid-range operating targets.
Distribution pressures normalize across urban and agricultural corridors.
Transmission input resumes standard operating rates without upstream intervention. System components settle into synchronized long-term operating conditions.